Today we're talking about log properties. The reason we study these is because we're going to have to be taking derivatives and integrals with logarithms and exponents this last month here. And we have to be able to do these properties. We have to be able to apply them in order to be able to do those derivatives and integrals. So let's look at this first one. It says log 1. Log 1. Well, if we don't have a base, the base must be 10. So this would mean 10 to some power must equal 1. So what's the answer? 0. The next property says this, that anytime we are multiplying two values, that it will actually end up being the sum of the logs of each one of them. This is not an intuitive formula, so I want to show you how it works. Let's say I have log 2 times 3, okay? That is the same, of course, as log 6. Those will be equivalent. But it's also the same as log 2 plus log 3. You see what I'm saying there? See how when it's multiplication, a lot of people think, okay, that would be the same as log 2 times log 3. But do you see how that is not equivalent? So whenever we have multiplication of two values, it has to go into the sum of those logs. Bless you. On the next one, log a to the n is in log a. So look at this one. This would be as if we have log, say 2 to the third. Is that answer? Look at how that's the same thing as bringing that 3 down in front. Same thing as 3 log 2. See how they're exactly the same answer. So this is our next property. If we have division, if I have log 2 divided by 3, what is this saying it's the same as? Log what? 2, just log 2 minus 3 or log 2 minus log 3, right? And see how those are exactly the same. Okay? So these are properties, they are not very intuitive, so you do have to memorize them. Okay, here are some special properties. This one says log base A of A. So this would mean A to the what power is A? What's that going to be? Anything to the what power would give you that number back? 1. What's the base if we don't see it? So this would be 10 to the what is 10? 1. And then this one, if we don't have a base for natural log, we just know it's a base of E. Guys, you could even type this into your calculator. Right here's the natural log bit button, natural log, and then the E button is right here above division. So natural log of E, what do you think it's going to be? 1. All of these mean 1. Okay, important to know. So what about if we're given some values and we want to come up with some other answers? So in this one we're given natural log of 18 to find. They tell us that natural log of 2 is approximately this, and natural log of 3 is approximately this. We want to use those properties to find the natural log of 18. What numbers multiply to be 18?
6 and 3.
Yep, 6 and 3 to start with. The reason I'm asking for multiplication is because these properties involve multiplication and division. So if I write this as 6 times 3, I don't know what the natural log of 6 is. So how can I break up the 6? 2 times 3. So I have this is 2 times 3 times that other 3. So now when I have multiplication, it's going to turn into the natural log of 2 plus the natural log of 3 plus the natural log of 3. So then I just plug it in. The natural log of 2, the natural log of 3, the natural log of 3, adding all of those up. And so there's our answer, 2.8903. Just using those properties to simplify. All right, look at the next one. How do we rewrite radical 2? 2 to what power? 1/2. So this is going to be the natural log of 2 to the 1/2. What did it say up above? If we have an exponent, it can become a coefficient. So I can change this into 1/2 natural log of 2. Now I can just use substitution. It's going to be 1/2 times whatever that natural log of 2 was. So typing that in, 0.34655. Letter C, we're given natural log of 3.3 repeating. How are we going to write 0.3 repeating? 1/3, right? So it's going to be the natural log of 1 divided by 3. What does division turn into? Subtraction. So it's going to be the natural log of 1 minus the natural log of 3. Natural log of 1 isn't listed though. So what are we going to do? Yeah. We could do 2/6. You're right. We could make that work. We can also make this work too though. What's the natural log of 1 going to be? No. Look guys, log 1 was 0. Natural log of 1 means e to the what is 1. If I get a 1 here, it means something to some power has to be 1. What is it? 0. So you might want to add that on too. Anytime we have a 1 in this spot, the log, the natural log, has to be 0. Okay, so this natural log has to be 0 minus the natural log of 3 was given. And that's going to be our answer. The last one's the toughest one. First of all, we have a cube root. Okay, so a cube root would make us have a what out in front? 1/3. So now we have 1/3 natural log. 0.25 is 1/4. Right? So now I'm going to think of this as 1/3. And then if it's division, it turns into subtraction. So it's going to be 1/3 the natural log of 1 minus the natural log. 4 is 2 squared. So I can bring the 2 down in front. You guys with me on that? If it's 2 squared, the 2 just comes in front of this. So now I'm going to have 1/3. What's the natural log of 1? 0. Minus 2 times, then I look back for the natural log of 2. So now I can figure it out. It's 1/3 times 0 minus 2 times 0.6931. And it's negative 0.462. One. Questions on that one? All right. Now, these are the two most important things. In order to be able to take derivatives and integrals, we have to be able to expand and condense. Expand means we're going to take something that's kind of small, and we're going to make it bigger to expand it. So if I have 3 times x squared, can you think of how that would expand to? Very good. Does everyone understand where that came from? It's a multiplication, so it turns into addition, and that squared can become the coefficient of the log x term. All right, what about this one? What do I do first with that 2? Bring it down in front, right? So it's going to be 2 natural log. Now, this 2 goes with the whole thing. Okay, it's 2 natural log. And I've got x squared plus 3. What does the division turn into? Subtraction. And what should I do if, instead of writing natural log of x to the 4th, what should I do with the 4? Yep. And that's the best answer. Guys, don't do this. I'll tell you a common thing people do. They think they can distribute through that natural log there. You can't do that. Like, here's what they would think they could do. They could do natural log, say we have 2 squared plus 3. We're just letting x equal 2. Okay, so that's the answer to that. Well, they think it would be okay to just do natural log of 2 squared plus natural log of 3. Do you see how that's not even close to the same thing? You are not allowed to distribute through here. So I can't write this as natural log of x squared plus natural log of 3. It's not correct. You can see it's not correct if I plug in a number for x. Okay? All right. Here's one of the most important parts here is condensing now. Writing it as a single quantity. Single, meaning 1 natural log, 1 log. All right, so look at this. We've got 3 natural logs. We have to take it down to 1. What's our addition turn into? Multiplication, just of what comes after them. Just what comes after them are getting multiplied. Then we have subtraction. What's that going to turn into? Division. Now, I have a 3 out in front, but what would that turn into? Cubed. Now, the cubed has to go here. Here's how I always see people write it on the quiz that is wrong. That rule does not say this whole thing is getting cubed. It says only this value is getting cubed, not the whole thing. That is wrong. Don't do that. All right. This one can be confusing as well. We've got logs. We've got 3 of them. We have to take it to 1. Where's the x go, on top or bottom? Top. But now this is subtraction, so it has to go on the bottom. This is subtraction, so it must go on the bottom. And then, do I put this 3, do I put the whole thing in parentheses and cube it? No. What is it that's only getting cubed? The x part, the quantity part. That's the way it should look. Okay? Guys, here's another reason that this would be going to the bottom. I know that gets confusing. If I made this a plus, I could really make this to the -1 power. And if I made that a plus, I can really make that to the -1 power. Can you see how now that would take them to the bottom? Sometimes people like to write it like that better because it makes more sense to them. Okay, good job. That's it. From here on out,